Section 2: Quantum and Experience. As Zohar comments on quantum locality, it is probably the most counterintuitive feature of the quantum world. As vision of reality which holds truck with instantaneous action at a distance, non-locality, as it is more properly called, the principle that something can be affected in the absence of a local cause, has obvious mystical overtones. In fact, it flies directly in the face of both common sense and classical physics. Both rest on the intuitive principle that reality is composed at some level of basic, unanalyzable parts, that these parts are inherently separate, and that any witnessed effect on one part has an attributable cause in some other part. Further, according to relativity theory, no cause, say a signal, can travel from one bit of reality to affect any other bit faster than the speed of light. Thus, any notion of instantaneous influences should be out of the question. The whole problem of non-locality is so difficult that it wasn't even raised in the early days of quantum theory, and it's only in recent years that physicists have attempted to come to terms with it. This does not mean that faster than light signals are possible. If they were, we could signal to our own past, and this seems unacceptable. And there are proofs by Philip Eberhardt and others that, according to quantum mechanics, any measurable influence must travel at the speed of light or slower. It would seem that the instantaneous correlations shown by Bell's theorem and the aspect experiments are, in the words of Nick Herbert, private lines accessible to nature alone. This thought leads him to ask the question, why does nature need to deploy a faster-than-light subatomic reality to keep up merely light-speed macroscopic appearances? In Unit 7, I will argue in support of an answer to this, namely that it does so to make consciousness possible. Hodgson insists that the world of experience must be composed of micro-objects, which only quantum theory can describe in a satisfactory manner. Therefore, the substantive reality of our experience, the macro-objects and events of our experiential world, is based on the reality of the quantum world. The macroscopic properties which we observe are relatively sharp and stable because they manifest the statistics of huge numbers of states and events of the quantum world. We perceive such properties because our perceptual apparatus in general responds to such statistics. So, for the intersubjective world of human beings, their relationships and their language, it is the substantive reality of objects and events which is primary, and the quantum world of codes which is secondary and derivative. Nevertheless, we can add that, despite our folk physical prejudices, the world is thoroughly quantum, from micro to macro, and there is no upper boundary after which we can safely revert to classical physics. On the subject of the non-materiality of matter, Hodgson says the entities described by quantum mechanics are very different in many respects from the substantive reality of our experience. They are both indeterminate, consisting at least in part of superposed potentialities, quantifiable probabilities for observed properties, and also non-local, capable of operating by way of instantaneous correlations between spatially separated events. Hodgson then asks whether the quantum physical descriptions represent entities and events which are real, or whether at best they are merely rules giving some sort of connection between the macroscopic objects and events which are the true reality. I suggest that the quantum physical descriptions do, at least approximately, represent entities and events which are real, even though these entities and events are difficult to describe and comprehend in our ordinary language, dependent as it is on concepts associated with macro objects and classical physics. What Hodgson is saying here is that our classical billiard ball conception of matter is based on the macro world we experience, while the reality of matter is based on the very different micro world of quantum mechanics.